Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Happy Tuesday to you, and a number of things as usual. Of course, your journals are out, of course. Homework in your lesson planner, of course. And here's your homework. I'm just going to tell you right now, we're in our textbook now. So your textbook should be tagging along with you. Bring it every day to class. So some days we'll use it, some days we won't, but bring that rascal so we can work with it. So here's your homework from pages 16 and 17. I need 6 to 8 neat, complete bullet facts on the white sheet provided about the Earth's magnetic field. That's pages 16 and 17. So read those pages, 6 to 8 bullet facts explaining the Earth's magnetic field. And by the way, it is a just right. One of the just rights, and we'll get at today the reason there is a magnetic field. Now what does it do? It blocks harmful radiation from the sun. That's why God created it. And which reminds me, yesterday actually, I read to you a little bit from Genesis 1:14, where it said, the stars also. It just sort of as an afterthought, kind of underspoken, not a big deal. But then when you realize what it means, that when the Lord created on day 4, what he created, sun, the moon, the stars also. That is 10 to the 22nd, we estimate, stars. Might be more than that. And they're organized into galaxies. So the fact that they're organized and there's a repeating pattern in the galaxies of the stars. If you've got a pattern, you've got to have a pattern-er. It's not random. So anyway, just a little reminder, are we going to use that information about the stars? Yeah, we will. So anyway, homework again, 6 to 8, neat, complete. You don't have lines on the white sheet, but they can be neat still, and complete, not just 1 or 2 words with your bullet facts about the magnetic field. Okay, now 7th grade, I have graded all your tests, unless you haven't turned them all in, if you're an RLO student, or if you were absent, and there are a few of you, a handful of you, who still have a test to make up. Make arrangements with Mr. Phillip to make those up by Friday, if you've got a makeup test to take care of. So, and I'll try also to message you, but if you know you've missed one, do it on your own. Take the leadership. Be responsible. Set it up with Mr. Phillip. Okay. Pardon me. From test number 4, here are some reminders. Many of you got most of these right. A few of you, all of them right on test number 4, 45 points. So reminders from the test. I'm going to ask you all of these again on Friday on your 5th test. Why are you asking us these again? I want you to remember them. You know that. Come on, you don't ask me that. The reason I, RRR, is so you will remember. So I'm going to ask you again. Pardon me. What are the 2 properties, characteristics of matter? Have mass, take up space. Now I've gone over that a number of times. You ought to get that right this Friday. So matter. Now you really ought to get this right. My goodness, there's still a few of you that miss this. What is a vacuum? And what is it? There's no air or no matter in a vacuum. Is it about gravity? No. Are you looking at and listening to me? Please don't put no gravity for a vacuum. That isn't its characteristic. No matter, no air, no atoms. And then, what do you call a measurement word everyone knows and uses? Standard unit. You ought to get that right. There's still a few people missing that. And you ought to know how much a gram is. It's equal to 1/4. If I tore this in half and then tore it in half again, 1/4 of a sheet of notebook paper. That's 1 gram. 1 meter is a little over a yard, about 3 inches longer than 1 yard. You ought to get that right. And then, what is a liter? It is equal to about a quart. How much? A quart in the English system. Now, I ask this question. What's so great about the metric system that you could have 1,000th of a meter? That would be a millimeter. You could have 1,000th of a gram, milligram, 1 milligram. You could have 1,000th of a liter, 1 ml, 1 milliliter. All you have to do to change the amounts. What would it be if you had 1,000 meters? Well, it's kilo, right? So kilometer, kilogram, 1,000 grams, kiloliter, 1,000 liters. So the beautiful thing about the metric system, all you have to do is change the prefix in front of meter, liter, or gram. Beautiful. I just love the metric system and how logical it is, how it makes sense, and how easy it is to operate once you start to understand it. All right, next question. I'm going to ask you on Friday the King Henry again. King kilo 1,000, Henry hecto 100, and so on. So you need to know it. So I'm going to ask you about that. I'm going to ask you what the little particles are that matter is made of. Atoms. Remember Democritus said atoms. Now he said they were, he thought they were uncuttable, undividable, that you couldn't get any smaller parts. Well, not so. Here is a helium atom. Does it have any smaller parts? You betcha. What? Electrons orbiting it. Protons in the nucleus. What's that? Protons. Neutrons in the nucleus. So it has smaller parts. More to that diagram in a bit. So anyway, smaller particles. And then, pardon me, what are the 4 kinds of matter? Matter can exist in 4 different states or kinds. Really packed tight. Atoms are packed really tight, really dense then. A lot of mass. What is it? That would be a solid. More loosely packed. Roll over each other, you can pour it. Glug, 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 glug. What state is that? A liquid. What do you call really a loosely packed state where the atoms just free float and take up the whole space in the container? Like a room. Like our room, 906 that you're in right now. What do you call that? A gas. And then on the sun, where the gases are heated up so hot they just fly around and smash into each other. What do you call that? A plasma. Plasma. Stars are made of what state of matter? Plasma. Super hot. So I'll ask that again. On the sun, what occurs? Fusion. They fuse. Hydrogen atoms fuse together. What? Hydrogen. Hydrogen. Fuse together. And what does it make then? Helium, which is the second most important element on the sun. And heat and light. To heat up the earth and light up the earth. Not an accident. Now, evolutionists say all of this is gradually evolved. It just randomly happened. Oh, please. That is ridiculous. That's just nonsense. That Remember specificity everywhere you look, including with the sun, including with stars, including the earth that we'll get at today, the layers of the earth. Specificity. I'm going to ask you that pretty soon. Do atoms have specificity? They do. So I'm going to ask you again on Friday about fusion. Slow-mo. Hydrogen, hydrogen, fusion. Helium is produced. Heat is produced. Light is produced. I'm going to ask you again. And then I've got the periodic table. Now, some of you missed this. I said, what are the names of the 100 plus kinds of atoms? They're called, some of you put periodic table. Well, no, periodic table of what? Right there, you probably can't see it on top. Will it focus? I don't know. Yeah, there it is. Elements. These are elements. Means basic. Basic kind of matter. Elements. The elements. The elementary. The elemental. So these are all elements. What elements do you have to know so far? Your PTE is out. PTE is out. Grab for it. You've got the two kinds of gases on the sun. Bookends at the corners. At the corners. Can I get them? Will they focus? Hydrogen and helium. Do you have to know the symbols? Yeah, by Friday. H4, hydrogen. He4, helium. Pretty easy. Okay? Then you've got to know, what do you call what the earth is made of on the inside? What metal? Iron. Number 26, Fe. And you've got to memorize Fe because it doesn't. Fe. Fe. No. It's iron. It comes from the Latin ferrous. Ferric, which means iron. Oh. The Latin ferric. Fe. For iron. 26. So you've got hydrogen, helium, iron. Then you've got the two gases in our atmosphere. And they are numbers 7 and 8. The atmosphere right here in the room, the little slice of it in this room, in 906. Mostly what? About 80%. You already know this. N for nitrogen. And O2 for oxygen. The 2 is 2 atoms. So one atom of oxygen doesn't usually exist that way. Usually exists with 2 atoms that have combined. And it's O2 then. O2, the 2 there, 2 atoms. Oh, that's what that means. So you've got those 5, and I'm not going to have you do Ni for nickel. The earth is about 15% nickel, but it's about 85% iron. Hey, in the 26 box, I'd like you to put E equals, how do I want to say this? The major, how do I say it? I don't know, however you want to do it. But somewhere in the 26 box, put 85%, and then maybe E for Earth. In box 26, it's right there. Box 26. Oh, you can't see it. Can I get it there? 26. It's not focusing so well today. So box 26, iron, Fe, about 85% of the Earth is made of that. So anyway, so just those 5 elements I'll ask you on Friday. I might add one more later in the week. Like, what is our skin mainly made of? What's the element of life that living things are made of? What is it, Mr. C? Well, I'll tell you now. It's carbon, C, carbon, and it's element 6. It's got 6 protons. That number that you see is for the number of protons. It's the atomic number for each of those elements. So anyway, so we've got hydrogen, H hydrogen, He helium, N for nitrogen, O2 for oxygen, Fe for ferrous, which means iron, Fe iron, and then C for carbon, the element of life. So you need to know those and kind of a little major story behind them. So you should have highlighted them and review them when you're triple R'ing. Okay? So review them. I'm also going to ask you, if I didn't say it already, the King Henry, I just mentioned it, I think. So the King Henry, yep. So you need to do it, know it. Okay? All right, I'm going to give you a quick little break and get any clarification from Mr. Phillip. And then in just a few minutes, I'll be right back. And I want to show you a mystery about atoms. It's pretty cool, the way God specifically designed them. All right, a little bit of clarification, catch up, ask any questions. Okay, I'm back. And here's the mystery. Look at this. Now you might wonder, hey, Mr. C, what specific glue did God use to hold atoms together? And he did use a glue. In fact, we don't know all the glues. It's too complicated. It's too complex. Atoms are too complex. We've only, in the last even 25, 30 years, been able to start figuring out other tiny, tiny parts that say protons are made of, and other little parts that atoms are made of. So 30 years ago, I don't think we knew about leptons, and I don't think we knew about gluons, and there are some others as well. We just didn't even know about them. So until we started using particle accelerators to slam atoms together and break them apart, and then try to figure out what the parts are as we break apart atoms. Well, now look at this. There are some forces or glue that hold atoms together. For instance, here's the first one. Probably going to ask you for one of these forces that glue atoms together that the Lord used when he created all matter. So check this out. Now you know right here in the nucleus. Nucleus, some of you didn't get nucleus. The center of an atom is a nucleus right there, nucleus. So, and I'll ask that on Friday too. In the center of atoms, there are positive protons. That's their electrical charge. And there are neutral neutrons. They have no electrical charge. And then orbiting right there, orbiting the nucleus are electrons, which have a negative electrical charge. Now, this is a helium atom. I think I asked you to draw one. Draw a helium atom really quick in your journal if you don't have one. Just do it really quick. Draw 2 protons with positive charges in the nucleus and 2 neutrons. It just has a plus and a minus together. See that? Two protons, 2 neutrons in the nucleus of a helium atom. It's got an atomic number of 2, just 2 protons. And then it's got 2 electrons that are orbiting with negative charges. Do you see them? So draw the 2 electrons out there. And you can draw kind of an arrow showing them go around or show them going all the way around. They're actually ripping around thousands of times a second. So actually, we used to think that an atom had this, how do I say it, diagram or form. We now think they're just clouds because the electrons are moving so fast, it's like a fuzzball or cloud, we think is the current model for an atom, a cloud of particles. Okay, you got them? So the first rule, or the rule of glue that hold, or the rule of attraction that holds the parts of atoms together. Opposites attract. Opposite electrical particles attract. So look at it. So you've got electrons out here, and you've got protons here. Positive charge, negative charge. Opposites attract. So the positive protons are holding or attracting the electrons so they don't fly off. It's one of the kinds of glue that God used to hold the atoms together. The rule of opposite attraction. I'd put that down somewhere if I were you. Are you going to ask it on Friday? Am I going to ask it? You know I am. The first rule of glue of attraction, opposite electrical charges attract each other. Positive attracts negative. Electrons, protons attract each other and hold things right where they are. Now look at this. There is a second rule of attraction, and look at this. And here's what usually happens. If there are particles that have the same electrical charge, they repel each other. They push each other apart. The same electrical charge. So, same electrical charge, push apart. All right, look at the mystery in the nucleus. You see the mystery? You should ask a question. You should look into the nucleus of this helium atom and go, why doesn't, and I'd like you to write your question in your journal. Just write it on this page that you're writing on. But write a question. Now everybody do this, not an option. Everyone participating. Mr. Phillip encouraging it. In your journal, you're looking at the two protons in the nucleus. And you just heard this second rule of attraction or repulsion. Like charges repel each other, push each other away. Opposite charges attract. So you should ask a question about the nucleus. Why don't, finish your question. Why don't those two exact charged, positive, protons push each other away and explode the atom? That's exactly right. Why don't they? Why don't atoms fly apart like the atoms in your body? The carbon atoms in your body? Remember I said living things made of lots of carbon atoms? Atomic number 6 protons. Why don't those 6 protons, which have all positive charges, push each other away and explode the atoms? Wouldn't be good for us. We wouldn't survive. Why doesn't it happen? What do you think? Make a hypothesis in your journal. Everyone, not an option. What's your hypothesis about the protons not repelling each other, pushing each other away? Why not? Write your hypothesis. Just a bullet fact. Quick. Why don't they do that? They should. It's the second glue rule. Mr. C, could there be some kind of force that overcomes the repulsion, the repelling, and that holds those like-charged protons together. There is. And it's a very strong force to overcome the repelling force. We've only discovered it in the last few tens of years. It's very strong because it has to overcome the force of repulsion. This is the second kind of glue that Jesus created. It's very strong. So what do they call it? Why don't we call it the strong force? That's what they call it. That's what physicists or chemists who study atoms call it, the strong nuclear force. The strong nuclear force that overcomes the force of repulsion and holds those protons together super tight in the nucleus. The strong force, the strong nuclear force. It's cool to know that, isn't it? Way to go, Jesus. That is just so cool. We don't even know all the glues. There actually are little particles that hold protons together called gluons. Why do they call them gluons? You know. They glue the atom. They help glue the atom together. And then there's gravity, but it's not very strong compared to the strong force or the force of repulsion. So there's 4 forces right there of attraction. Are there others? Probably. The Lord is so complicated and so complex. Is he just going to use one simple force to hold atoms together? He could, but he didn't. It's real complex, real cool, isn't it? So the strong force, I expect many of you, when I ask on Friday, name at least one of the glue forces or attraction forces that hold atoms together. You're going to say, you can't use gravity, it's too weak. I'm not going to take it. No points for gravity. Nap, 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 nah. So you've got to have, you can have the opposite charges attract. You could use that. You could use a strong nuclear force that holds those protons together. You could use gluons that hold protons together. So those would all work. Okay? So anyway, all of those would be good. Okay, you did homework, and you're going to turn your homework in, where you had to write up what are the different layers of the earth and what are they made of. You were supposed to bullet fact all that. So you've got the crust, the mantle, the outer core, and the inner core. Crust, it's solid rock, and not very thick compared to the other layers. The earth is 8,000 miles in diameter. So the thin crust, not much of that 8,000 miles. Then you've got the thicker mantle. It's hot rock. Rock that's hot and sometimes so hot that it doesn't melt, but it's like, it's not a liquid, but it's like starting to melt, kind of. I'm trying to think like clay maybe, kind of. Like clay. It's so hot. And then you've got the outer core, which is super hot and liquidy, and the inner core, which is solid. The inner core is solid because of the pressure of all the rock above. Solid. Now, I'm going to stop there and teach you more of that tomorrow, but I want some of you, to all of you if you wish, I told you you've got Orion high in the southern sky right now, 7:30 to 8. Orion looks like a cross. It's on its side, so you've got the N stars, and you've got the belt stars of supposed a hunter, and those 3 stars in the middle, N stars, belt stars, 3 in the middle, they point down to the brightest star we can see in the night sky, Sirius. Sirius is maybe the most beautiful star that we can see from Earth. Is it the biggest? No. But it's closer than other ones, so therefore it looks bigger and brighter. It's big, all right, and I'll tell you more tomorrow. So anyway, Sirius, like a lot of stars, seriously, Mr. C, twinkles. Twinkle, twinkle, little star. Please don't sing anymore, Mr. C. Okay, I don't want you to lose your lunch if this is after lunch, or your breakfast if it's a morning class. So stars twinkle. Why do they twinkle? Because the air in the atmosphere of the Earth is moving, and it moves the light from that star. It bumps it all around, so it looks like it's moving all over the place. So it twinkles. Stars twinkle. But listen to this. Sirius twinkles seriously in a very special way. Because of it's so bright and producing so much light, the light from Sirius is not only bounced around, it is changed into most of the colors of the spectrum. So if you look at it with binoculars, you can see a bunch of different colors. I'm showing you a photo of that right now. You're seeing the different colors that Sirius produces. You're seeing those different colors. Isn't that cool? Now, you can go out and look at it, and you might see a few of those colors. But if you use binoculars, you'd probably see more. Or a telescope, if you had a telescope. Now, I'm offering this for 10 points. Done it before, but go out and look at Orion, 7:30 to 8:30-ish, high in the southern sky. And you've got the N stars, the three belt stars, pointing down to Sirius. So just right, I saw Orion and Sirius parent signature turned into the box during the month of February. 10 points. 10 points, 10 out of 10. Easy peasy points. So go for it. So anyway, I'll give you a little time to work on your homework. Pages, 16 and 17 on the, just verifying on the causes for, there it is, 16, 17, the causes for the Earth's magnetic field. 6 to 8 bullet facts on that white sheet. So work on that for a little bit until Mr. Phillip says it's time to shut down. So see you tomorrow on a short day, remember, half day, on a half day downhill day, Wednesday. See you then. Bye.